In this video, we're going to take a look at a little proposition. We have three functions, f that goes from a to b, g goes from b to c, and h goes from c to d. So we have functions, and we're going to show that we have a left and right identity for the composition of functions, and the identity functions are going to play that role, these roles. So we have left and right identities. And in B, we're going to show that the composition of functions is associative. Okay, so here we're going to show that we have associativity. Now let's start with our first statement. To show that two functions are equal, we need to verify two things: that they both have the same domain, and codomain, and they both assign elements in the same way. The first is always very easy. We have the function f that goes from a to b. Then we have our identity function that goes from b to b. And then our composition necessarily goes from a to b, because it is the identity circle f like this. So both our composition and f go from a to b, so the first step is done. The second step, we need to verify that those two functions assign the elements in the same way. So we'll start with an element in the domain. Let x be an element of a. We have the identity circle f of x. This right here, by definition of composition, this is equal to the identity of f of x. And notice that f of x is an element of b, and the identity of b over b sends every element to itself. So here we're sending f of x to f of x. So this shows that our composition sends x to the same element as our function f. Now, I don't think you should be very mad at me if I leave the one in green as an exercise. It's pretty much the same thing. For now, let's prove that composition of functions is associative. Just as in A, we need to verify that those two functions right here have the same domain and codomain. So we have A, we have B, we have C, and we have D. F goes from A to B, G goes from B to C, H goes from C to D, and this A to C, this is G circle F, and B to D is G circle G, H circle G. And there you have it. Both functions start with A, so our domain is A, and our codomain is D. Next, what we need to verify is that both functions assign x, an arbitrary element of the domain, to the same element in the codomain. Let me bring that down a little bit. I'm going to start with the left side. So H circle G circle F, and this function is evaluating x. Now this is a little difficult to read at first. This right here, our square brackets, is one function, which maps x. And what's going on inside the square brackets, we have one function right here and one function right here. And then in the parentheses, this function right here and this function right here. What this is equal to, remember when you're looking at G circle f of x, this is equal to g of f of x, okay? And first, we're going to consider these as our two functions. So this is equal to h of, and then our second function, which is g circle f. So h of g circle f of x. We do the same thing, but for g circle f, okay? This is equal to h of g of f of x. And we're halfway through. All we need to do now is to go backwards in our steps, but in a way which we will recover this function instead. So here we can consider h circle g. Okay, we have h circle g, which evaluates f of x. So of f of x. And then again, one last step, we have h circle g circle f, and then all of this evaluates x. And there you have it. We have this function right here, which assigns x to the same element. Hence, we can conclude that for the composition of functions, we have left and right identities, and we also have associativity.